Ladies and gentlemen, may I have your attention please? In a short while, we'll begin the afternoon session of AICON Gwangju 2023. Please make your way back into the venue. Thank you. Once again, ladies and gentlemen, in a short moment, we'll be continuing with the afternoon session. Ladies and gentlemen, please make your way back to the venue and take your seats. In the afternoon, please make sure that you put your mobile phones onto silent mode. We'll begin momentarily. Thank you. The world of AI shining here. We are now here at AICON Gwangju 2023. And here I can see that the passions and the insights are all over the around this place, and that makes Gwangju even brighter. And we will now continue with the next session, where we'll be meeting with speakers with insight and professional knowledge. Please look forward to it. And the fifth session is themed AI and healthcare, focusing on the future of medical services combining with artificial intelligence. Without further ado, let me introduce to you our first speaker, Dr. Kim Yong-jin, Director of Seoul National University Hospital Research Institute of Life and Medical Sciences, will deliver a lecture on advancements in AI, digital technology, and the future of healthcare. Please welcome Dr. Kim with a big round of applause.
Thank you for the introduction. Hello, I am Kim Yong-jin from Seoul National University Hospital. In Gwangju Institute of Science and Technology, this is my first time visiting here, and I heard that it is your 30th anniversary, and congratulations, and thank you for inviting me to this event. I am a normal doctor, so I participate conference and symposiums, and this is the first time I am concerned that I might know less than you. And I am not here to tell you about a brand new story, brand new information. I will share the knowledge that you already know, so please understand that I am briefing from the perspective of expert. 10 years ago, as a presenter, I have never dreamed about giving a presentation about AI, and I think lots of doctors agree with me, and there are many theses that is related to AI in medical journals. I think you all know about this. In 2000, maybe some of you have not born in 2000, and in 2000 there was new millennium. So people thought they were going to get their computers damaged, and New England Journal of Medicine, this is the top medical medicine, and the editors said that for the last 1,000 years, they have selected 11 medical development. It includes anatomy, cells, elucidation, anesthesia, and immune system. There are so many developments, but I am sure that the rest of 1,000 years, AI will be the top development that changed the medical sector. So far, medical was changed by doctors, but from now on, medical will be changed by AI technology. The first, when doctors got very shocked by this AI development, was this 2016 AlphaGo. This was in 2016, and it's been less than 10 years since AlphaGo shock hit us hard. Starting from 2010, Google collected all kinds of images to label, and they gathered about 10 millions of images, and then they make the AI to learn, and this is a blood vessel in retinopathy, and this is the only artery that you can see without cutting your cell tissue. So when I was in medical school, we used to see patient's eye to see the artery, but if there is a diabetes, there can be an also disease in your retinal fundus, and AI can diagnose that disease also. And other than that, there are so many theses that is related to skin disease. This is malignant and benign skin cancer. And you can see this red dots and 6 uh, green lines. And actually, there are 20s of skin disease that can be diagnosed by AIs. So AIs can diagnose better than medical school students. And as you can see, there are so many radiology and radiology related videos that can show the advancement of AI. This is a chest x-ray, and lung nodule was missed by a doctor, so after a year this has developed into a cancer. So if you go back, then it will depend on the age of the patient. Then if this happens, the doctor should have to face a lawsuit. And this also applies to pneumothorax. This is a system that SNUH is using, and it is very difficult to get lots of information with chest x-ray, but you can detect with AI, and these AI system is actually utilized in our emergency room, and also brain disease, brain hemorrhage. So cardiovessel and brain vessel related disease is very much time sensitive. So when we take a CT photo, we have to show this to doctor, we have to scan this, we have to print this, and there are so many processes that are related. But if you look at this you can get the result as much faster. So mortality rate in 1 month is much more improved thanks to AI. And have you ever done a colonoscopy or endoscopy? And if you go through colonoscopy, you will probably get a adenoma if you're unlucky. But it is very difficult to detach adenoma, and you need to be very skilled doctor in order to successfully detach adenoma. So how well you find and you remove adenoma will make the patient not having cancer in the future. This is overall research data. This is adenoma, which is less than 10 millimeter. And if your device is equipped with AI device, then you have high chances of discovering adenoma. What is very surprising in cardio is electrocardiogram, ECG, because ECG interpretation was done by computers already. When I was training, I had to use a compass divider to measure all the number, but you don't have to do that work anymore. But if we use AI in this step, of course, the important reason of ECG is to detect arrhythmia, and it can detect arrhythmia, of course, because it is AI, but with ECG, AI can see what people cannot see, what human doctor cannot see. So if you look at this graph, it is almost the same. But the patient on the top do not get sick. But if you look at the bottom, there is atrial fibrillation during sinus rhythm. But if you look at the ECG from this, AI, human doctor, can never distinguish both two, but AI can distinguish this. So if you look at the actual data, this red line is the prediction result of AI with atrial fibrillation. And with this result that is derived by AI, we can predict and we can prevent having heart disease, which is atrial fibrillation. And this is heart sonogram. Even though you have never saw this before, you will notice that the left is beating normally and right do not beat normally. You have to do sonogram in order to know the normal condition of heart, but ECG can detect this without any sonogram. I have never dreamed about human doctor being able to diagnose these symptoms. But what is more surprising is the graph you can see on the right. AI had predicted that the heart function is lowered, but you can see that the model predicted patients with EF of less than 35% by ECG alone, and still very surprising. Currently, startups in Korea was approved by FDA, and now they are selling this device. With ECG, they can distinguish gender, they can know your age, they can see the calcium level of yours. And in our hospital, this is the result of ECG. It says that normal ECG result. Mayo Clinic is the fastest developed and most developed AI developed hospital, and they started like this. They see ECG, they see that it is normal from the ECG interpretation result, but if you look at the top, you can see ECG age. What does this mean medically? We don't know, but if you look at the next one, you can see the probability of low EF, and then you can also confirm probability of HCM and also probability of AF in one dashboard. So we cannot say the entire medical sector is established with this much of dashboard, but the era of AI supporting the diagnosis of disease will come soon. I cannot say medical quality, but medical efficiency, effectiveness should be improved. I'm not sure if you have went through MRI before. It takes about 30 to 1 hour in a small machine, and you will hear a big noise. And if you don't like to be in a small cell, then you won't be able to go through this. And with this technology, the acquisition time has decreased about 30%. With the signal node ratio, they're all improved. And also for CT takes a little time. But what is concerning is the radiation. When you get radiation, your chances of cancer will also increase. And if you shoot a chest CT over and over again, you will be able to see any cancer if there is it in your chest. So we try to use a lower image CT, so that capacity had decreased about 75%, and with small radiation you can get better image quality. These are all possible with AI technology. So with AI technology you will get better quality and better cost effectiveness. And you can also predict pandemic in the future. These all have one goal. It is all about one task. So one machine learning, one deep learning task cannot change the medical field. So only using one function will take you a long time. So what we need is foundation model. Foundation model is about inputting all the data you have, and then you make a request and get the answer. We call that generalist. Generalist is opposite of specialist. It is not about doing just one work. Generalist is doing all the work. So it takes CTs, it takes video, it makes diagnosis, and also you put in medicalization information, and it all can applied like this. It can play as a patient's chatbot, it can interpret photos, it can support on the bedside. X-ray interpretation through deep learning is just about module read by AI. But here, generalist medical AI will give you the results of interpretation like professor. You can see the endoscopy results, and then if you want to know about the colonoscopy result, then AI will give you the answer and help you with making decision with procedure. So in the past, all the machine did was taking photos of your colons, but now it can help you make better decisions. And this is representative large language model. This is a neutron developed by New York University. And in the past, they used to make the algorithm to predict the mortality rate, but all they need was the medical record, and they can actually predict the reconstructive rate and also the death rate. It would be very good for the hospital, but for people who are working in hospital, it is also good because it is very difficult to make a constructural database and analyze that done by a human. And if you have this technology, you can overcome this limitation. ChatGPT can be representative technology for that. So it took only about 30 seconds to pass bar exam in the US, scoring more than 90, and that is a huge development. And I saw this for the first time in the thesis, but if you look at here, it said it took the exam on March 21 in 2023, and it shows how fast it can learn. So US MELI questions are popped up, and you give the answer, and it can also explain why this is the answer and why this is not the answer. And if you want to make B the right answer, you have to change the medical record and medical diagnosis opinion. And then ChatGPT can not only answer the question, but also modify the question. So when you want to make question for the exam, you have to make the right reason, and it should be reasonable, and it should have no error. And if you look at the next line, the student made C as the best answer, but this is not the best answer. But this machine is able to explain that this is not the answer. So we thought this machine had learned a lot, but I'm not sure how the machine figured out why C is not the answer. And this is a patient with abdominal pain, and first few days we say the condition, we say the temperature condition, and this is the daily record. And if we put in all the record inside, and this is a normal standard result of patients, and this is very important for educating medical students, but we need to be able to compare this with compare normal condition and the condition I have on my table. And this year, I mentioned this journal to you before, and this is a special report from that magazine. I have never thought about this issue will be on the report, and it says that AI in medicine benefits, limits, and risk of GPT-4. So we provide this function. We ask, what is metformin? Then we ask, can anyone with type 2 diabetes take it? Then it will answer that if you have bad kidney, it is not recommended. And what are the other options there? And then there will be other options that will be written by GPT-4. And if the human makes error, then the GPT will probably say, please discuss that with the other person. And human ask, why do you know about this disease so well? And GPT will probably say that I got the master's degrees, and this can be one of the hallucination. So when you say there's an error, then it will modify immediately. And there should be more technologies that can resolve hallucination issue, but there are some issues that can be overcome with the right prompting. And we can one more time ask if the answers are correct. And when you go to hospital, you're not able to see patient's face because you're so much concentrated to computer monitor. You can see X-ray result, you can see patient's record, and Naver also has similar solution. So if you just make a conversation, AI will going to record that automatically, and that will automatically create medical record. So it will make the better relationship between doctors and patients, but also dialogues are very important for the record. So I think Korea should also work hard to develop the technology. And also there is bedside support, and there can be some consultation that can be provided for better bedside support. If you look at this article, it says that will GPT-4 be the technology that finally transform healthcare for the better? I think it will change things 100%. Of course, there are more rooms to develop, but before that, we have to resolve black box issue and causality issue. Sometimes we don't know why this is called cow, and there is a possibility of wrong answer all the time, and this is a huge concern for doctors. And causality is a concern because we make premise of treatment, and without defining the right treatment, it won't work. So that is the reason why this should be resolved. So I haven't had enough time to explain all of this, but if you look at this medical research, this pink is a hormone, and this protein is immediately created, and normally it takes a long time to make this simulation, but now it is so fastly created. And when you want to develop a new medicine, and you always have to concern about clinical trial, because you have to select the subject patient and you have to make decision with the number of patients, and this is very important point. And consultation company for these clinical trials, they design your clinical trial for better clinical result. And if by using the AI, these designing can be more effective. This is a triangle in healthcare. Quality, accessibility, cost should be all fulfilled. But it used to be have a low quality or a high accessibility, and it was very difficult to fulfill all. And this shows the different death rate of caused by heart failure depending on different regions. So people say that doctors should move to those regions, but doctors don't move because they don't see that much patients if they live there. So we have to overcome the gap of technology. So in order to do that, we need to have wearable devices, and wearable devices will be the core. And with these devices, you can get the cost and quality issue all solved. I said that heart and brain related disease is very time sensitive, and we call this a golden time from balloon time. So door to balloon time. When patients comes in, we have to enlarge the bronchial system with balloon, and it is very difficult to get all those process within 90 minutes because you have to calculate the time of patients getting the car and coming to the hospital. But if this starts from the moment that they call, then it will save us a lot of time. And this is our pilot project, which is electric intensive care unit. ICU is very important to see the prognosis, and if it is possible to see the patient from other area by Seoul National University, it will be very different. We can see the condition of patient with different types of wearable devices, and these days I never touch patients. We just encourage patients to cheer up. We can hold their hands, but we don't have to touch patients because it can all be seen through the monitor. And this technology will be more developed in the future, and all surgeries will be recorded, and it will be like video games. You put in endoscope and you just watch and then you just play. So this means it is very easy to learn. Like autonomous driving, autonomous surgery era will come soon, and this will be representative technology. So ultimate future will be AI not developing medicine, but it will change the medicine. There are some patients who get their COVID-19 test at home, and soon basic medical care can be done by yourself at home. And in order to do that, AI should get the FDA approvals, but there can be many problems. It can differ depending on different sites. AI model that's learned in Seoul National University can have a poor precision when it moves to Jeonnam University, and this gap will increase if we are talking about different countries. And it is very difficult to differentiate different data, and we have to use the data from the US, and we also have to think about the ethnical characteristics. In that respect, Seoul National University Hospital has huge amount of data. So we have data of more than 6 million patients and packs of more than 4 million patients, pathology data, millions of patients. And with these data, we can build SNU Hub, and this will be established in December. So patient information is all will be opened. So you can visit and you can see the ECG result, and you can make machine learn with the data that we will provide in December. So there should be more collaboration. What collaboration? The future of medicine will not be decided by doctor, it will be decided by engineers. So staff and students in GIST and Seoul National University, we can cope with each other. Thank you.
Thank you very much for your presentation. Let's give another big round of applause to Dr. Kim. Thank you. Let's now move on to the next speaker. With the recent introductions of OpenAI's ChatGPT, there's been a growing interest in AGI, Artificial General Intelligence. Open source-based diverse generative AI models have been released, sparking lively discussions about the potential introduction of generative AI models in the healthcare sector. Today, we have the privilege of having Dr. Jung Yu-chae, Assistant Professor of Korea, Open Cyber University. Please welcome with a big round of applause. Hello, good afternoon. First of all, I have to say that thank you very much for the opportunity. Thank you all involved in Global AI Conference. Today, I'd like to talk to you about bringing generative AI to healthcare. Well, first of all, there is a growing interest around generative AI. Large text are learned and trained, and the text can be created. This is what generative AI is about. One example is Google Spot or ChatGPT of OpenAI, and this generative AI model, if it's applied to healthcare sector, what is it that needs to be considered? First, I think I would need to introduce to you about the area of artificial intelligence. It was very well explained before, and as you can see, AI technology is widely applied in the healthcare sector. And this is what we call the medical AI, and visual, linguistic, judgmental, and the automatic categorization, summarization. These are the areas where we see AI application. And as all of these are integrated in the area of generative AI, we see the potential of its application in the area of healthcare. For example, for the new drug development, when it comes to the case selection, or for the reading assistance, and the reading of the pathology, and also a data-driven precision medicine that is used for genomic analysis or diagnostic prediction. These are all the potential areas where generative AI can be utilized. And it can also be used for the medical assistant, and I believe that with that, we'll be able to efficiently improve the quality of healthcare, and we will definitely see the huge impacts of it. And as you can see, there are some AI-related softwares, and one example here is Puno, and there are some other companies like Brunit and so on, and they are now going through this clinical test process and trying to pass the Korea FDA's approval. And for those software that is approved, will be recognized as a medical device and will be used in the industry. And the generative AI, if it's applied to the software, then we can expect broader functions that it can offer. So with the advent of these generative AI, I think we need to understand the background of it. So the chatbot technology actually started to emerge quite a long ago in 1960. And the very beginning, it was rule-based and the search-based. But as we moved into 2005, there was a new system called goal-oriented dialogue system, which is represented as Siri or Alexa. And after 2015, there's been a use of large-scale database, which brought the QA models into life, which we describe as deep question and answering. And now it is developed into generative AI, where human-level talking is possible in the form of ChatGPT, for example. As it was mentioned, the generative AI can be applied in various areas, including text summarizing, text generating, including the sentiment or emotional analysis, or information extraction, text creation, and correcting typos. These are all potential areas where we can see the application of generative AI. And one big example is Bard of Google and ChatGPT. And these generative AI models, once it's incorporated with the Google search engine or maps and emails, we see the use of it everywhere in our lives. And there are a lot more language models. I mean, the OpenAI's been releasing GPT's new versions, and Google has been releasing medical specialized model like PaLM. And there's also Bard that is specialized in general questions. So we've seen this development, and let's think about if this generative AI can be used in the hospital setting. As you may know, this model has been providing the service publicly, and every data that we input will be moving to the server, and there's a potential risk of privacy infringement. So the information cannot be uploaded as it is. And to resolve these obstacles, open source based large-scale language model need to be established. So there has been different releases, and depending on the model, some are only allowed for the research purpose. Some can be used in the commercial setting. So depending on the purpose, it can be used in the hospital setting. So this generative AI model, when it was used in the hospital setting, what are the specific areas that we can see the use of it? First is for automated documentation and medical record retrieval. And if there's an error or if it requires complemented information or improvements, AI can be used. Another use would be clinical decision support, and for supporting researchers or supporting searching papers and so on, the technology can be used. And when the repeatable patient communication is required, the technology can also replace the human needs. And also for the medical records or health status are analyzed for predicting health outcomes can also be done by the generative AI. And another usage can be for the personalized treatment plans. Other than that, there's area like medical education or ethical and compliance monitoring. Google announced various generative AI models, and among that, the healthcare specialized models exist, and let me introduce to you. First one is called BioBird. This model trained the data in PubMed and PMC, and it is a specialized and dedicated model for the healthcare sector. It's not a generative AI technology, but it understands the natural language and perform various tasks. So it's an initial language model. And as I've mentioned, there's this thing called BERT model. So after going through the BERT topic process, then it collects various medical papers by different topics. So there will be a clustering of work can be done, and there's TF-IDF algorithm that is already known, and if this algorithm is applied to BERT, then we'll be able to see this topic-based model. So to this BERT topic model, if we train this patient note history, this is what we see. So the training would extract 8 topics, and you see similar words are bundled, and we will be able to find the information by different topic for different disease. So the semantically similar words will be clustered and shown by topic. It is indeed an advanced model. And as it was introduced already in 2023, there was this paper on Nature. It is about generalist medical AI. Once it's applied to healthcare sector, it is going to reshape the paradigm of the healthcare industry. It was what the paper was about. And as you can see in the paper, the generative AI can, for example, analyze the health images, and even it can capture the genomic data, and these data will be analyzed, and through reasoning it can be applied to various areas of the healthcare sector. So this is what the paper is saying, and here are some examples. And first example is about the patient's medical record and audio, text. All these will be analyzed to identify the status of the patient, and if the patient is suffering from diabetes, if there's a need for something, that the alert will then be raised to the doctors so that the doctor can deliver the proper care. And through reading this medical image, for example, the bone image, after reading the image, the report will be automatically produced. And also, there sometimes need to repeatedly explain the procedures to patients, but the generative AI can replace that so that they can reduce the burden of the medical providers. So this generalist medical AI's emergence will bring the paradigm of the healthcare sector in 3 aspects. The first is controllability. This difficult medical knowledge can be translated into the easily digestible form so that the general public can easily understand what's been written in the reading and the reports. And the second is adaptability. What I meant by adaptability is that the foundation model can be applied so that the similar issues can also be resolved. So what I mean by domain shift is, for example, what was resolved in one department can be transferred to other departments so that it can help them resolve the challenges that they are facing. So with that, they'll be able to secure this artificial intelligence model. And the third is applicability. It can be evolved into an infinite number of downstream application models, and if that happens, it can apply to different services of the healthcare sector, and it can run the healthcare service efficiently and more easily. And the next is what's been released by Google. It's called MedPalm 2. It's a very specialized generative AI model. MedPalm, this language model is based on generative AI, and the pre-learning trainings are already complete, and it has verified how far it can apply to the healthcare sector. As you may know, there are life and death situations in the healthcare sector, so hallucination and wrong or errors can have a huge impact. So this model will verify all these areas of concerns. And this paper, when the paper was out last year, the accuracy was 67.2%, but within less than a year of time, with this repeatable verification process, the accuracy is now up to 86.5%, and it is now further verifying whether all this technology can be actually applied into the healthcare sector. So when we have this outcome from the analysis that incorporated AI technology, how the data can be shared among different hospitals. As you may know, in the hospital setting, the personal data or personal medical record cannot be going outside the hospital, so the actual sharing of data will be impossible. So even if we have analyzed utilizing the generative AI, there needs to be an issue with sharing, right? So the sharing data itself will be difficult, but how? There's this way called federated learning method. It allows hospitals to share the processed form of a patient's medical records. And to make that happen, the analyzed data need to go through the standardization process, and this is what we call the common data model. So these information would need to be standardized, and there's this organization that oversees this whole process called OHDSI, and there are a lot of research going on, and the basic information like the age or the drug history and the disease history and how the procedure, how the process was like for the patient. So for all this data, there will be a set standardization. They can shape this form of data so that this form of data can be shared. So for such data, there will be a standardization of terminology, for example, and with the consensus among different hospitals. How far we define as common data, these are the areas that needs to be agreed and discussed. So I've talked to you about a lot, but to sum it up, in the area of healthcare industry, to really introduce AI, there are three things that needs to be considered. First, as there's a life or death situation in the healthcare sector, there needs to be the highest accuracy and reliability. And the data in the medical sector is very abundant and holds a specialization. So specialized data is what we would need to see, and the data itself should not be biased. So there shouldn't be the issues of biases nor ethical related issues. So these are the areas that we would need to prepare. And lastly, I'd like to wrap up my presentation with a few policy suggestions to resolve these bias-related potential issues. There needs to be discussions around ownership of healthcare data, and also we would need to find a tool that can prevent these issues from happening. And the standardization effort at the national level would be also important. So that ends up my presentation. Thank you very much for your attention. Thank you. Thank you for your informative presentation. Ladies and gentlemen, please give another big round of applause to Professor Chong. Thank you. And now we are here at the last session. In Korea, there are 4 leading institutes of advanced science and intelligence known as KAIST, UNIST, DGIST, and GIST, which is Gwangju Institute of Science and Technology. We have invited the professors representing this field of artificial intelligence from these 4 institutions, and let's now introduce the first speaker. The topic of the presentation is the space intelligence for robot autonomy. In the lecture, there will be introductions around the space intelligence technology. Please welcome Professor Myung-hun from KAIST. Please give a big round of applause to the professor.
Thank you for the introduction. You said I represent AI, but I don't represent AI. I will share the small portion of the work I do. I am working with the spatial recognition, which is one of the AI technology. The movie I, Robot was released in 2004. Have you watched this movie? There are 3 technologies that appeared in iRobot. One is self-driving car, and the leading roles was trying to drive the car, and then the female say that no manual driving. And there's swarm robots with hundreds of robots, and lastly AI is controlling the entire building, and also humanoid appears. So iRobot has these 3 features. And when do you think this is? Do you think this is 10 years later, 20 years later? We only have a few years left. The background is 2035 in Chicago. So imagine this will happen in the future. I don't think this will happen to us that much soon, especially autonomous driving. Renault and Cruise, they are providing autonomous taxi service in the United States, and recently there was a crash accident. Cruise did not see a person who was lying on the ground after a car accident, so after that the transportation authority had banned the cruise driving. So AI is not intelligent enough as much as people, as much as human in autonomous driving. So I think there are still long ways to go. And now I am studying autonomous walking, autonomous moving, and I am one of the people who will contribute for that technology advancement. And this is the work I do. We do spatial work, and we also study robotics, and we also make autonomous locomotion and drone and swarm robots. They're all our research range. Today I will explain about trends of intelligent robots that I discovered, and autonomous robot navigation trend, and also autonomous flight, walking, exploration robot. I think you've seen these before. This is Spot Mini on the left, and on the right this is Atlas. They climb stairs, and then they do parkour movement. So this is all model predicted control. So this movement is possible only when the robot has understanding of the environment, and robots should activate in an accurate movement. So with all that being planned, this can be controlled. This means the robot cannot perform well if it's not in the planned environment. And recently, this is a reinforced learning environment, and this dog moves faster than human in Shui. By using this AI, the machine learned about the visual and tactile information, and it showed that it can run faster than human. So this was manually controlled by human. So people were walking in distance, and you cannot control all the movement on the stairs. You make a command that go forward, then it automatically climb the stairs. This was a huge trend last year. I will skip the video. And this is Cherry's University drone experiment. And also, it flies faster than human pilot. The one we just saw was a reinforcement learning, but this is imitation learning. So with this simulator, all the learning occurs. So it makes an environment that is very much similar to the actual environment, and human can fly like playing games. There are candidate trajectories, and you select the most optimal trajectory so that drone can fly that way. So we call that imitation learning. So it will be controlled by model controller. In this wild environment, there are lots of trees, but you're still able to thrive. The machines are very good at flying in this environment. So this research showed the capability of imitation learning, not just the reinforcement learning. And if you want to make autonomous vehicle, you have to make sure that the vehicle understands all the environment, and it involves deep learning. And if you want to make it move, you have to have a map created. And if you are in a urban area, you have to have trees, and GPS do not work at underground, so you have to know where you are. So radar, lidar, and visual sensors are necessary. And if those are equipped, we can plan the path, and we can control the movement along the path. Like I said, if you are exposed to an environment that you don't know, it will be very difficult to generalize or localize the map, because without map it is very difficult to localize, and without knowing the exact location it is very difficult to map. So in the first environment you have to resolve these two issues, so we call it SLAM, simultaneous localization and mapping. So my research lab is developing SLAM technology, and we are developing graph-based sensor fusion for dynamic and feature-poor environment. So we have made good accomplishments recently, and also for feature-poor environment, we have also developed algorithm. I think you know about ICRA. ICRA is the world best robot-related symposium, and recently we went to London, and in case of LiDAR, we got the first place. As for vision, we got the second place. This is a technology good SLAM in a dynamic environment. Let's take a look at the video. So what kind of technology do you have to use in order to know where you are, know your location? So green is static and red is dynamic. So feature rates are continuously updated so that you can also get the information of yourself, your location information, but also your surrounding information. So compared to other research, we got the best result. I said that we got the first place in LiDAR data. The award itself was given by Oxford University, and during the Sheldonian Theatre construction, we can use LiDAR vision IMU information collected, and if that information is delivered, then we will be able to see the location of the person and also see the 3D information of that surrounding environment. And we have created this algorithm. So depending on the space, the point cloud number differs, and this technology makes the stable number of the pixels. And this is the soft algorithm. And as for fast Rio, it went through the passage, but it had made judgment that it went through. But for ours, it said that it went through the passage, and then we were able to get the exact 3D map. As for vision, we developed UV SLAM recently, and this is unconstrained line-based SLAM using vanishing point for structural mapping. So this is line-based SLAM algorithm. So we are using the algorithm that is specialized for vanishing points. So when we made measurement for the information, if it's fully observable, then it can say it is fully observable. So we add vanishing point factor so that it can accurately map the surrounding environment. UV SLAMs are better lined, more organized lines, and you will get high accuracy, and also it had been proven quantitatively. These can be applied to different situations. First, let me explain you about the drone application. Using camera and IMU information, you can have SLAM algorithm in operation, and also if you add 3D LiDAR information, you can also optimize the information, and then you will have the better understanding of your own location. So we call this GV SLAM, and we have performed many different tests in different environments, and we also went to a turtle ship and then had it tested. If you go underneath the bridge, you won't get GPS signals, so it will be very difficult to get your location information, but we utilize vision and LiDAR, so we can get this white trajectory information. Can we move back a little? There's this 3D map, and let's move on to the next slide. If you look at the back part of the video, the bottom of bridge is recorded with high definition camera, and with that information it can see if there's any crack or any abnormality, and also the height information or other information can be recorded, so those records can be referred during the maintenance. We had some difficulties of wind, because if it's windy, drones cannot hover. So drones that we developed hovered and then attached to a structure and performed the inspection. This was developed in 2015. Now we have modified version of our drones. So drones can be attached on different surface. It can attach on brick or any wall type for inspection. So there is a camera underneath, so it can see the video from the camera in real time. By utilizing the technology, we can clean windows, and there's also firefighting drone. Firefighter needs the information of the place with fire, and they need to find the ignition point, and they need to find the people that they need to rescue. So this drone was developed, and this drone is capable of enduring 20 minutes of 1000 degrees Celsius, and it can find the source of the ignition point. And in a disastrous situation, there is a possibility of wall falling down, and there is a wall climbing technology. So with wall climbing technology, it can monitor and supervise the condition. And also, this is aramid fiber. It is packed with aramid fiber, and it can go through this narrow area like this. And this is wall wiping technology. There's a cleaning brush on the drone. The one that we just saw, that drone was able to twist, but this one can move 90 degrees. So without any impact, it can clean smoothly, and then it can come back safely. So in case the power off, we can attach the drone during the cleaning process, and after the cleaning is completed, the attachment point can be detached and then removed. It was very difficult to teach the machine because we already had nominal control equipped, because there was a controller that we used to use. Controllers are operated only on the situation that we know, but if there is any chaos, the controller did not work properly. So in order to overcome that situation, we used reinforcement learning, and if there is original state, we made adversal state, and we measure the disperse of the adverse. And if disperse is huge, that means low uncertainty. So depending on uncertainty, weight is given, and from the nominal control, there's a hybrid type born. So control input was done, and then we can see the drone is flying in a good condition. This is exploration. For this drone, we only give the information to explore the area. Then this drone will find and explore frontier. And it makes its own judgment for the optimal way. So this is path candidate scanner. So the drone select the best path. This is power conduit, and there can be sensors for ignition point, or any kind of sensor can be attached here. So if those sensors are attached, it can be explored automatically. Currently, people are checking each section one by one, and it is very difficult to inspect. And There was a KT fire accident, and the fire was not detected because it was not done by a machine. Last year, we got the winner prize from the 2022 Future Challenge Defense Technology Contest. There is LiDAR sensor, vision sensor, IMU, Zapier, NXS processor. So all the calculation is done in embedded mode. The reason why we used Zapier is because it was AI algorithm, and our goal is to get ready for the battlefield competition. And when you go out for a watch, then you need to gather all the information that is available. So you have to use algorithm to classify it. That's why we used Zapier export, and we also used exploration algorithm and also location algorithm and planning algorithm. Let's take a look at the video clip. This is the starting point, and when you start the drone, there's nothing that human can do. So there's nothing that human can do. So drone should make the progress itself. It will automatically find the frontier and then find most energy efficient section and least dangerous section. These circles are for the prevention of clashing. It goes 3 like this, and it automatically makes 3D map at the same time. This drone should know the location, so in order to make accurate 3D map. And if it moves by, this section is closed, so drone should go up the stairs. So it goes up the stairs and exploring the second floor. AI algorithm is working. This is the location of the enemy, which is spotted green. And you see another item, another enemy. The location of the enemy will be annotated like this. And here are armories. Armories are marked in red. This is how it goes. And after completing exploration of the second floor, it will come back to the starting point because there are no way out other than the entrance. Can we go back a little? The video? Okay, let's move on. There were 10 teams with the mission, and our team is the only team that was successful with this mission. And we are also working hard for the autonomous navigation of legged robots, and we are developing a spatial AI for autonomous navigation, and we are also collaborating with other institutions. What we need to do is a VIO development for quadruped. What we focused on was quadruped robots. Location recognition was so difficult because sometimes the legs were jammed or slipped. So we tried to come up with a solution to prevent that. So we used to have non-slip assumption. So all the equation was based on the assumption that it won't be slipped. So that was the hypothesis. But we were not able to ensure that, so we removed that assumption. So we made pre-integrated foot plastered effector foot velocity and IMU information utilizing foot velocity, and also joint angle calculated foot velocity is assumed to be similar. So this is an assumption with irrelevance of slipperiness, and in a various slippery conditions or rough condition, the result doesn't matter. And this shows that our algorithm works fine. So we integrated all the technology and we made this quadruped dog robot walk, and the location of walking is very difficult. Was difficult to determine because this dark green section is the section that the robot can walk, and other colors are other object where you cannot walk. We got a good result with this thesis. And also, when you walk a long passage, in a slam we call it roof closer because you have to come back, and it is very difficult to detect the roof closure. So that's why we came up with Quattro++. Based on that, we can robust global registration with ground segmentation. And if it's too far, the existing algorithm could not make this in operation. This Quattro algorithm is also developed from our laboratory. Transportation, rotation matrix, and transportation information all can be get with Quattro++. With all this involved, we can make a long distance driving with good matching. Let's move on to the summary. Global registration and local registration used ICP algorithm, interactive close point. Convergence is very short, so for short cloud it works, but it's long, it cannot. So based on ground segmentation, we applied different techniques, and now it works well. And that is the result of our thesis. There's a video at the end. This is Lego Loam, LiDAR-based SLAM algorithm, and we attached Quattro++ upon. It has similar performance, but in a small loop. But if you go to larger loop, it won't work on Lego Loam. But Quattro++, it is much better. We utilize all these testings, and this is how we have conducted field test. And this quadruped robot did not walk well before, and location performance is pretty okay. After walking 23 minutes, the tolerance error is about 20 centimeter. So performance is good, fine. We used the existing controller, and this is how it walks. If we use the existing controller, this is how it goes, and it cannot climb any stairs. And also, even though we use a robust technique, it did not work. So we made blind locomotion. And we teach all the learning process in simulator. So we only use a joint sensor. So we do not use the vision sensor, we just use internal sensor information. we also utilize the sequence related to the internal sequence, and we make one estimator. Estimator creates latent vector for the surrounding environment, and that latent information and elasticity zone we're going to make a critic structure. This is a simulator, so we all know about ground tools information. With height of stairs, they're all collected, so we utilize privileged observation to teach value network. We create critic and we make calculation for the robotics, and all these can be learned inside the simulator. And when we have done this, RTX 3 Ti GPU takes about 1 hour to learn. After that, it will be sent to SimTrial because there's no gap because of the randomization was very good. 4,000 robots are all different. Weight, length, the weight, center, performance, they're all different. Width, height, and the level of bumpiness, they're all different. So in a different environment, it is all zero shot applied. So let's take a look at a video clip. This is blind locomotion. The reason why we have LiDAR is because we had to do SLAM algorithm, and we are collecting SLAM algorithm data also. Proprioception means using internal information only. When it goes up this stairs, it do not use any external information. When it goes down the stairs, it never use external information. It is blind, so it can make wrongful steps, but it can automatically balance itself. We have conducted experiment in a harsh environment, and even with this high stairs, it can climb. The height and width is all different, so it was very difficult to climb. And this is a flat area all of a sudden, and if human can climb this with their eyes closed, it will be very difficult. But this is all calculated in 1 millimeter second. Humans' reaction time is 0.15, but it took only 0.005 seconds to react for this robot. Like I said, in an ISAC gym, we conducted reinforcement learning. It did not walk at all, but after an hour, it can walk, it can climb. And also fall recovery. Robots can also fall down. And we also made a robot to learn in reinforcement. And if it climbs, we gave reward, and if it did not, we gave penalty. Thanks to this technology, we were able to win the contest of quadrupled technology. So you just saw this robot falling down. There's slope like this, and in a situation with this falling down, it recovered, and then we got the score without any penalties. There were 11 teams in this contest: MIT, Carnegie Mellon, IIT, Hong Kong University. They participated. There are 5 sections which are all very challenging. And in the pre-final, these were all flat, but at the final, it became more complex. We used this proprioception, which is called DreamWalk. We used LiDAR and vision sensor because it had to walk autonomously. This is a SLAM algorithm, much accurate map compared to fast. This is based on ADAL algorithm, so I said we named it ADA LV. Kinematic information of legs are all included. More accurate map is created. Vision information is written, but sometimes vision information cannot be collected properly, so in that case we can use deep step. In this case, by using joint information and IMU information, it can know the location of itself. And this is Vince stereo, but for us, we did not use that stereo, but we still made the estimation. When there's a map, we can use the map for the location recognition. In that case, we make judgment for the better information, and then we can utilize that for better localization. Next is point cloud information. When we get that information, we get information with this blank, but it will be difficult for us to use that, so we need to have interpolation technology. If you look at the traverse map, there's very smooth, no gap map. Here is the elevation map. We have not released this in our thesis yet. I think you can expect this at the end of this year. And also global planner. We utilize risk information. Sometimes there are sections that is risky and sections that it's not. So we warn the robot with red color. And so red colored information will be calculated so that it can guide it through the unrisky path. Of course, if you have a map, if you don't have a map, you don't have to do this. You can go right into the local planner. This is local planner, and sometimes there's sudden obstacle, and it is making selection for the best pathway. If there's no map, we don't use the second one. All we need to use is the last map. So we utilize the technology recently so that we can make various motions. I will skip to the next. This is also reinforcement learning. Just by 2 legs, it can walk like this. Quadruped pattern can be differed depending on the velocity command. demand. And in this reinforcement environment, we can give reward if it performs the task successfully. If this can happen, it can also open a door. A humanoid robot can be applied with the same technology. Our framework is applicable to humanoid robot or drones, any kind of robots. So how we can better train the policy network is our advantage. This is a robot for the underground resources. To conclude, we have a spatial AI, and AI spatial technology has many ways to utilize. As for aerial vehicle, unmanned surface vehicle, autonomous underwater vehicle, and also in the European countries, they are trying to send four-legged robots to the space, and we will try hard to make this technology make utopia. This is end of my presentation. Thank you.
Thank you very much, Professor, for your informative presentation. Please give another big round of applause to Professor Myung. Thank you. We are now continue with our next presentation, and the topic is image motion deblurring in microcontroller system. This lecture will introduce micro deblur, an on-device image in motion deblurring solution designed for vision systems based on resource-limited microcontrollers. Please join me in welcoming Professor Lee Sil-ki from UNIST. Hello, good afternoon. My name is Lee Sil-ki. I am from UNIST, and my department is Computer Science Engineering. Thank you so much for inviting me to this event. My major research area is this, and I am going to talk to you about what I study and how we utilize embedded environment. So it's a brief introduction about myself. As I've mentioned, I'm from UNIST. My major research areas around embedded systems, machine learning, AI and AI plus IoT, cyber physical systems. So the name of our research lab is called Embedded AI. Process data, how these would operate the AI. What we do is we look at this fundamental methodology, and that can be wearable device, there can be drones, there can be autonomous vehicles, whatever the system is, that can be the subject of our research. So if you're interested in our lab, please type EAI lab in Google, then you'll find more information. So before I start the presentation, maybe I think we should start with what it is about when we talk about embedded deep intelligence and what are the potential challenges. So when we talk about embedded system, it does not mean the traditional computer systems, right? Laptop systems. We're not talking about that. Why is it that the small-scale device systems are important? If we start with the question, we see there are numerous such devices around us, including smartphones or 3D device. Most of the devices, I believe, are in the form of embedded system. And from hardware perspective, there are a lot of them, and from software perspective, again, there are a lot of them. So it's very fragmented space, and you see various ranges of products are out in the market. So why is it that embedded system is important? We can find it in the statistics. So if you look at the computing device, this newly developed device and their numbers are starting to outpacing the traditional devices. And you see this big data is from mostly the small scale devices. Why? Because they have sensors. So now we see these small scale devices as the mainstream. So the computer and the traditional devices no longer are taking up this space. So if you look at the AI and the studies around it, it requires a huge amount of data. Like, for example, ChatGPT, it requires millions of GPUs. So if you think about it, individuals or any organizations cannot really handle it. That's why few tech giants are making the developments in the area. I think this can be accompanied by some societal issues, like the issues around dependency, inevitable dependency, that can possibly put some individuals at the corner of this space. So whether it's a smartphones or a smartwatch, or whether it's an autonomous vehicle, operatable, effective AI is definitely what we need. And if you look at the embedded deep intelligence, well, this is a kind of a new terminology. And if you look at the existing service to enable intelligence service, there needs to be the communication between embedded system and the cloud server. But that is no longer the case. If the embedded deep intelligence is actively used, they don't have to send the data to the server. It can happen at the edge of the small-scale devices, and this is what the embedded deep intelligence is all about. So, what are the advantages then? First thing is first, sensitive privacy or personal information will not have to go through the server. So it is free from security related potential issues. For example, what we discuss, what we say within home, the data does not need to necessarily go through the server. So because of this feature, you see, it can also have an advantage of low latency, because sending the data to the server takes time. So the real-time characteristic is another thing that's notable. And lots of embedded systems and edge devices are running on the battery. But if this embedded deep intelligence can broadly used, we can reduce the energy and we can increase the battery efficiency. If you think about the wireless communication, the data that is required is huge. So we can actually reduce the energy that can be used for sending and receiving the data. Lastly, if you think about the data device that can even do the training, the customized AI will become reality. That is, your version of AI will be possible. So, for example, the ChatGPT is utilizing a single or two models that can be used by everybody in the world. But if you can specialize the data for yourself, utilizing embedded deep intelligence, there's a huge advantage of adaptability. So this is now gaining more and more attention. This is not only limited to small-scale devices. Especially in terms of large language model, for training, millions of GPUs are required. But these efficient AI or inference training algorithms, when they are applied, we can also apply this to the larger model. So it is very scalable, I would say. So there are these advantages there are these pluses, there are these newly emerging trends. But of course, we cannot avoid challenges. The biggest challenge, I would say, is that think about the small size of memory, and the process is relatively slow. In terms of GPU, it's a kind of a luxurious embedded device, right? And if you think about it, well, sorry, I think I got the order wrong. And for some applications, there's a time constraint factors in terms of autonomous vehicles. I mean, they need to, for example, identify an object within certain seconds, right? Otherwise, there'll be an accident. But to meet that requirement, it's going to be very difficult. And another thing is this embedded platform. It has various hardware architectures. There are different environments, there are different companies like NVIDIA. So this intelligent task to implement it in this fragmented environment will be quite challenging. Also, another thing is that if the data is gathered and if we try to, train the data online, then quantitatively or qualitatively, it will be pretty hard to gather quality data. I mean, for the training, there needs to be refined data, but in reality, the data is very scarce, and there can be these data-related challenges. The last challenge that I have to mention here is that the numerous number of devices will be run on data, so we cannot really avoid the large energy consumption. So how to resolve challenges in different aspects and how we make it as efficient as possible. Operating and training and doing inference, I think this is a challenge that we need to look at. And one example is this. We have announced it the beginning of this year, and the title here is, as you can see, so what we're trying to do here is that, the very small microcontroller that is MCU-based system, the blurred images, how we make it clearer. So what we want to do is we want to implement that with a small device, implement the technology with a small device. And why is it that it's important? Well, first, this small sensor data, there are more than 1 trillion images, there are 1 trillion photos taken by these embedded or IoT devices. So we no longer take cameras with us, right? We are relying on the small devices, and there are more possibility that the small devices will be used in a smaller embedded devices. So if you think about these large number of photos that are taken by the small devices, that is one thing. And the thing that we'd like to resolve is that, let's say that this device, this small camera is now in the small device, and then we cannot really avoid the blurry images. For example, let's say that the drones are moving fast, and of course there are some functions that prevent from moving. But this is what we call the blurry effect. In contrast, making it clearer is what we call the deblurring. So this uniform blur effect will be applied to every single pixel using the technology. So this blurry image, it does not only drop the visibility, but it also lowers the performance for the downstream vision task. For example, let's say that we have this blurry image and we put it in the image classifier. The classification accuracy will also drop. So de-blurring is the way to enhance the performance of the downstream vision task. So in the research here, what we call the image deep blurring. It requires resources and a lot of computations. We try to as efficient as possible so that the image on the device, if I be more specific, with a low-end microcontroller in the environment, we want you to see that from happening. So the problem that we wanted to solve is very simple. Basically, when there's a blurry image, we want to make it non-blurred by utilizing a small technology involved sensor. So this is what we call the blind deconvolution. If there's a clear image by block corner K, this blurry phenomenon happens. So what we have to do here is that this clear image, the kernel that made the clear image blurry needs to be estimated. So we have to resolve this part. This is what we call the blind deconvolution, and we wanted to make with as minimal resources as possible. So what are the ways that are being used? There are a lot of them. First is, you see the devices. We can load external sensors, so we can track how the device moves. So let's say the device moves from left to right, then the blur effect will be applied. But we can, by tracking them, we can restore the image to the original state. But this would be accompanied by cost, and in the small wearable device, this is really very critical part, and it does have its own limitations. And the second is using the most recent, latest deep learning method. It is very good at deep blurring, but the problem is that computation resource is required at large. So it is really hard to implement that in a small scale device. Lastly, what we can do is by taking multiple images, we see how device moves, and we can improve this blurability. And that is a good way, but it requires the camera to take multiple pictures, and that would cause some latency or some time. So real time will not be possible. So what we wanted to do is we wanted to resolve this with a single image. There are 3 steps required. First is we do blur kernel estimation that makes the original image blurry, and then we have to transform the blurred image that can be easily restored, and then we do clear image restoration. So once again, estimation, we make it into this particular matrix, and with the information, we do a bit distortion maybe, and then we restore it as the clear image once again. Let me be more specific. So first, what is required is modeling. So let's say there's B, the blur image B is the value when the convolution matrix is multiplied by the clear image, and there be added noise. So this is the modeling that we've done. When the given B, what we have to do is we have to figure what I is, and the H will be the matrix that caused the blurry image. And if we take the other way around, then you can find this function. So if you think about the strategy, well, mathematically speaking, it would make sense. But the problem is that H and I, those 2 are unknown. So that is why blind deconvolution is required. Our goal is we need to figure out what the H inverse is. But the H inverse, it's hard to figure that out. We don't know H, and this function can be challenging because there are unknown elements. And another issue here is that various devices would move multiple times, and when we use timestamps and there be a motion blur accumulated, and how we should approach. So that needs to be integrated. So I can't go into too much details, but we see it as a single blur effect, and then we assume it as a blur corner, and then we try to find the inverse matrix. So there are some conditions that need to be considered. The first is brightness is constant. The second assumption should be objects are not moving. These are actually realistic indeed, because the shutter opening time is a few milliseconds. So these can be quite effective. Not 100% maybe, but still. So blur corner image accumulated, and then it's integrated in single G, then we do the estimation, and we restore following these steps. I'm gonna skip over the detailed part. So the first step is this. So the blur corner that caused the blurry, then what we have to do is, if it's unknown, we have to do the estimation. And the deep neural network that is computationally efficient is what we try to find. This convolution-based deep neural network is what it is about, and for different channel, independently, the convolution is carried out. So the depth-wise convolution and the point-wise convolution, comparing to that, their efficiency is 10 times higher. So if you input the image, the blurry image, then what happens is that the blur corner that caused the blurriness will be identified, as you can see, and then it will be estimated as an output. So this kernel that caused this blurriness, the convolution corner, let's say we have the value for that, and then we have to make it as an expanded form of matrix. And a particular form, to be more specific, toy plate matrix is what we work on. So you see A, B, B, and this is the characteristic of the toy plate matrix, and it only requires row vector and column vector. So the space that the matrix is saved, we can reduce it much, and previously figured the K kernel will be now changed into this form. This is H, right? And why is it that we want to convert it to a toy plate matrix? There are several explanations. First, it is easier to calculate the inverse. We can calculate the value in most cases, but there's no guarantee that we can always calculate the inverse. That is why we need to convert it to toy plate matrix. And in solving linear matrix, linear equation, the complexity is relatively low. The end time is also relatively low, and as I've mentioned, it only requires 2 row vector and a column vector to store. And the space complexity compared to the existing method is relatively smaller, so that it can now be onto the very small micro device. So we have figured out the blur corner can, and now it has to be converted into H. So that's the kernel matrix. And now we make it as a vector. We have to convert the blur kernel matrix into a vector. And then you see this KCC with the K blur kernel. We can make the row vector as well as column vector. So you see on the top is row vector and on the bottom is column vector, and with having these two vectors we will find the Toeplitz matrix HT, and now that way we can find H value. That's H for us to find this inverse. But there's a problem. Because we put it now Toeplitz matrix form, this blurred image, due to it's not that it's not converted to Toeplitz H. If we go more specific, what you see on the top, it's what when it's converted to the original matrix, and on the bottom we give some constraints and convert it into Toeplitz matrix, and how the blurred images would differ. So you see the yellow box part is the same, but one thing that is notable is that on the right and on the bottom, what's indicated in red is different. So we need to give some changes to the de-blurring. And this is why we would need to do the blur image transformation. We need to convert the value so that it can be applied to the Toeplitz matrix. So B converted into BT would need to go through this process, as you can see, and the depth-wise convolution, depth-wise inverse convolution will be more effective, and again, this would require pre-training. And so everything is ready now. We have blur image BH, and now what we have to do is we need to resolve these linear equations. So we have this blur image B, and we know H, and then the algorithm, that is this Toeplitz specified algorithm called the Levinson-Durbin recursion, repeatedly it can solve this equation given B, H, what's I. This algorithm effectively can solve this equation, so now we can have the value for I. So this is the algorithm. So because it's converted into the Toeplitz matrix, you see that this time complexity and space complexity got largely reduced. And to resolve this general matrix, in terms of time complexity, space complexity, they're very low. And you see that this methodology can be explained as hybrid because it mixed up the existing and the deep learning method. And we have now put the camera inside, and then we input a large data set, and as a comparator, we have put these multiple elements, and if you look at the result, it is measured with SSIM and PSNR, and you see that the microtubular is run on microtubular, and the rest are run on GPU and CPU. And if you look at it closely, SSIM and PSNR, there's no huge difference in values. And here's the result. The leftist one is clear image, and then blurry image, and then de-blurred image, and this utilized the microcontroller system. So from human eyes, we see that it's not too bad, right? So this deep blurred image, we put downstream vision applications, and we have looked at classification, detection, and segmentation. You see the three lines. This deep blurred image, when we put into the downstream vision, we can see that performance can improve. And lastly, from the resource perspective, memory, comparing to the algorithm run on a GPU, it was more efficient as much as 187 times and 4.8 times respectively. And of course, comparing to GPU and CPU, there is a huge energy consumption up to 429 times. And in terms of latency, it was 26 times slower than GPU-based solutions. But if you think about this a million times difference, 26 times slower result is not actually too bad. And that wraps up my presentation. And we introduced what we study in our lab, and we gave you an example of micro deep learning. Thank you very much for your attention. Thank you. Thank you very much for your informative presentation. Ladies and gentlemen, please give another big round of applause to Professor Lee Seul-gi. Thank you. Let's move on to the next presentation. Our next presentation is on the topic of research on the scene understanding generalization for autonomous driving. With the recent groundbreaking advancements in deep learning technology, there has been a significant transformation in the field of visual perception of autonomous vehicles. In this lecture, we'll be looking into the strategies and directions of next generation of visual perception AI technology to achieve high generalization ability and integrated reasoning capability in artificial intelligence. Without further ado, let me introduce to you Professor Im Sung-han from DGIST. Please welcome with a big round of applause.
Good afternoon. I am Professor Im Sung-hoon from DGIST, EECS department, and I am working as AI professor at the same time. Today I would like to explain about generalization study on scene understanding for autonomous driving, and I would like to focus on generalization. The technology that our laboratory is currently developing can be utilized as quadruple walking. When AlphaGo first came out, AlphaGo just played Go, and as AI being advanced, AlphaGo can play chess and also other board games. So it can work more than one task. It can work on more than one work. And eventually, Zabis, that is also AI from the Iron Man, and that is our goal, to make AI that can function like Zabis. So one neural network is not using just one task, and it should use different tasks. As for Zabis, we need to find the visualization and also object recognition not only on sunny days but also in rainy days, and there can be issues when we are trying to find and detect those objects in rainy days. And there are cameras in many different devices, in DSLR, smartphones, and resolutions are all different. So depending on the specification of cameras, the images that it can contain also differs. And I think generalization is necessary in this field also. Today I would like to talk about the three perspectives of generalization study. And we are mostly focusing on autonomous driving, so I will explain based on the video data that we have collected during autonomous driving test. this was from Tesla AI Day. And if you look at this video, there are cameras equipped on vehicles, and this can calculate the location but also the distance between the vehicles, and also lane information, structural information, traffic light information, also and stoppage sign information. And with all this information combined, the vehicle can finish the operation safely. Tesla and other manufacturers do not just attach one camera, it attaches other cameras, rear, front, and sides. At least 5 cameras are attached in autonomous vehicles. From the cameras, we get the information about the environment, not just about sunny days, but also suburban area information, highways, and we need to expand the scope of the recognition. And in this different situation, we need to process the video data that are collected from different cameras. Creating algorithm that is very good for embedded environment had been explained by other professor, but now I am going to explain about the small, not just the small power usage vehicle, but I will focus on the number of neural network, the decrease of neural network. If there are many cameras attached, there will be one neural network for one camera, and if the autonomous system is not generalized, it should be trained in different environments, and it should be modified. And also for visual recognition, 2D object recognition is necessary, but it also needs to track the distance and trajectory, and also the location of vehicles should be known, and this is the direction that we are trying to take. And as for the first issue, this is about deterioration of visual intelligence, and we call this multitask learning. The often occurred issue from multitask learning is negative transfer. When we have independent network for each task, the accuracy was about 70%. But if we want to integrate this into one, then if we infer to just one network, then the negative transfer will occur, because for one network, 3D boundary box finding task and segmentation task is all independently working, and it should have each independent features. But here, just one network is taking care of 2 different features. That is why the transfer decrease. And these are multiple situations that we may face when we want to autonomously drive, and this had not been found during the training process, but sometimes the performance rate goes down during the actual driving. And also the sensor issue, mobile DSLR sensors, and also LiDAR-based visual recognition is very oftenly used, but depending on the visual information, we have to use different LiDAR information, and based on the wavelength, some points are detected, but with other wavelength, the same object cannot be detected. So this issue is also one of the issues that we need to solve. And this was conducted with Hyundai Motors. Vehicle had learned the data And with the same model and with the same camera attached on truck, the performance goes down drastically. So today I will introduce problem number 1 and 2 and also problem number 3, and I will tell you how we have worked on these 3 problems. This is the first problem, generalization to visual perception task into one network. Multitask learning that we used to use before, this, if we want to make one neural network to solve this multitask, what should we do? This is not, and we have different heads on different tasks. We call it hard parameter sharing. So number 1, 2, 3, and 4 has common feature, and each has dependent task, and from that task we can extract specific feature. In the hard parameter sharing technique, we can have more advanced technique, which is mixture of experts technique. So it moves from one network to other network, and each task has different weight. So the first task has about 10 features, but the first 2 tasks will be more focused, more weighted. And number 2 will focus on number 5 and number 6. And this is how it works. And some research is skip or select, so we can skip certain nodes and connect with other nodes. The commonality of these research is whether or not how you design your neural network, the sub-topology, the network structure itself, will be all feed-forward type. As for inception net, we call it network structure. So each neural network inside, there are more complex network structure, but it cannot be expressed accurately because it should use the same neural network. So from our laboratory, we used the specific network for each task. So we used the neural art search function. So we make node connection as much as we can, and also we draw complete directed acyclic graph. And each task can be decided for each task, and you can make a more specific neural network and parameter, and that is the direction of our research. After the research, we can make this feed-forward structure or make other node connected from one node to different node. So we can have numerous topology. That was the main idea of our research. This is one of the example. We have one central network, and parameter of this network is already decided underneath. And as for this 3D object tracking, it has this password, and this can skip to this way, and it can be connected to the topper node, and the bottom node will not be used. And if this is learned by machine, then neural network will be able to make this connection automatically. It has a mathematical algorithm structure, but it is very difficult to explain here, so I will explain briefly with this photo. There are network connections like this, but from the first layout to the last, if we connect all that and then do the search work, it will be very heavy. So we should make a settings with the hyperparameter. There are only 5 connections from the start, and then we do the searching. And the input layer should be all connected, and output layer should be also connected. And we can create this adjacency matrix, and there's one flow reduction step. So we initially train, and this is the planning stage, and at the search stage, warm-up stage, and in the search stage, we decide whether or not we kill or we save the node. and among the living network, if there are some node with weight, we disconnect that and we can make some adjustment and then make structure that is more adaptable. After conducting learning process, we can see this parameter sharing. Starting from 1 to number 5 node, they're all equally connected, and last two heads are existing separately. So if we call that number 1 and number 2 parameter, according to the network structure that we conducted, there were about 5 nodes that were connected for search. But in this case, only 37% was increased, but the performance increase was about 95%. But if you compare, the parameter number goes down, but performance will go up. So this will not be applied only on classification, but that's normal. And we call this heterogeneous genius multitask. And we call the other one homogeneous MTL. Heterogeneous MTL, homogeneous MTL. All of those showed a huge performance increase, 13 point and 9.5, about 15%. And if you connect that with the segment depth, there are 5 tasks that are all connected, and the performance also increased stably. And like we have intentionally made, do those have each sub-network? And if we look at the segmentation network, if you look at the right pink path, it is all connected. And surface normal network, it is all marked in green lines. And if you look at the number 1 to number 12, 3 tasks are all shared, and not from 6 to 7, they're only using segmentation node. So we have proposed the first study, and this is about a training scheme that is finding the first network. In that case, the feature goes up, performance goes up about 10%, but parameter did not increase that much. But as for the weakness, it is almost the same, but during the computation process, you have to share with the activation map. So in terms of inference time, it is still threefold higher, but according to the recent work, we have set some of the value. And this is the second study that we have conducted, and this is generalization to the environmental changes. During the daytime, when we conducted testing, we wanted the performance to be stable. And by 2012, we used to solve this issue by using style transfer with an image. So we create an image that fits the circumstance. And if we make the machine learn, then that will make easy to generalize. That was the approach that we took in 2012. But after that, we made some thoughts, because these neural networks, if those are less biased in terms of style, then we may get better performance. So we have thought about it. So for the first, there's this thesis. This was published in 2019. You have a photo of elephant skin, and then you show a cat, and then human will probably say this is a cat, and CNN will going to do the classification, and this elephant texture, if this is combined, then the human will probably think this is a cat, but CNN might think this is an elephant, because as for human, we make judgment based on shape, but CNN sees texture more, so they're texture biased. So we took some survey And as for transformer, it is not entirely shape biased, but compared to CNN, it is shape biased, but if we compare it to human, it is text biased. So we make this similar data, and then we ask question to human being and make judgment made judgment if this is text biased or texture biased. After we transfer all the information, we can classify all the data, then that shape detection will be about 1. If not, the text decision will be 1. So at the left, humans are all shape oriented, but machines are more close to the right side. We've applied this to depth estimation task, and plus we have analyzed why this happened. And in neural network design, generalization was achieved with triple I release. And why did this bio had more shape biased characteristic, and there was this bio characteristic? The network structure looks very complicated, but feature was imported like this, and there are other collateral contributions, but that is irrelevant. But if we want to make a important judgment, we have to make judgment with some of the modified text biased data. And you can see the style change into red, and these shape cannot be detected. But in this case, the network that we suggested will be trained with the general, has been trained with this general data, but the result was not bad. And also, neural network trained with QT was also tested at night with robocar, and the performance result was okay. However, CNN performance result was very poor. And additionally, we asked question, and we performed some analysis. And as for self-supervised method and that in-depth network learning and supervised method learning method, and we can make that with the SOTA standard. And also there's monoformer method, and we have to make decision if we want to use a transformer or Timmins or Reason BRI or SLAC or CNN based methodology or ComboMax. We try to see the different methods, and then we try to find a trend. So what is marked in orange are transformer based, and what is marked in blue is CNN based. And circles are self-supervised, and triangles are supervised. So circle and triangles are not important, but most orange transformer based by methodology has the characteristic of shape biased, and most blue CNN based are texture based. So when we conducted this experiment, we generated this sketch, and based on the video that we created, we entered the CNN and transformer original image. And when we want to make the similar feature, then this network finds shape more. This is how we set the experiment, and this is how we confirm the result. So most transformer were cited on the left, but if you look at the region VIT, It is mostly texture, but more shape-based. It is because the characteristic of region VIT. Region VIT will have a local patch, and feature encoding steps are inside that. In that case, that is very similar to CNN's characteristic. CNN is 3 to 5, 5 to 5, and it goes through encoding process, and with the different layers, the scope will be widened. And it is known that there are that local inductive bias, and I think region VIT is opposite from that. And as for transformer, it is all based on self-attention. So based on self-attention, you get the patch and self-encoded. So in that case, rather than CNN, this local texture is not just the important one, but we have to see the broader scope. And we can see that there can be a broader feature of this scope. So that was one of the generalization experiments that we have done. And lastly, this is for a sensor system. Like I said, each vehicle have its data set, train data set, but if it's attached to other vehicle, the performance will go down. We've tried to find out the reason, and Hyundai Motors updated the neural network without any labeling, and it made the machine learn with that updating method, and it came up with more practical solutions. So in order to find the radical reason, accurate reason, there were few experiments that's been conducted. In 2D experiment, we wanted to know if the same thing happened. But for 2D detection, no matter how much image is rotated, how much the location has been changed, the performance did not change that much. But for 3D detection, if the rotation is harsh, the performance will go down to about 90%. So we have thought about why this happened, but 3D network, the 3D bounding blocks do not occur at once, but it starts from 2D detection box, and then it goes to the information of 3D, and then it collects the information of location and the size of the box and location information, and that is all collected and combined, and that is how it is predicted. But we have made observation with heading direction for the bounding box with just one angle. That is why when the camera location or rotation angle changes, the rotation information is wrongfully entered. So if you look here, using the original data, we have looked at the baseline performance, and it was about 11.3, but if we, under the roll 3, it is about 1, and during pitch, it is about 2, and it is very similar. And 3D bounding box has the hypothesis and assumption that it has the roll and pitch. So there is no assumption with the roll and pitch. So that's why we easily solve the problem. So first, this is the initial training model. With the initial training model, you put the video from other vehicles, then you will get inaccurate estimation result. Most vehicle manufacturing companies, so they have X, Y, Z, and camera angle information all understood in advance. Then there can be relative position between the cameras. Then, so without further estimation, just by using the information you have will make you possible to make the right estimation with the some level of compensation. Some feature had increased about 80%. So in this study, we've analyzed different items and we have conducted research related to those items, and the original was about only 11%, and it was because of inaccuracy of depth estimation. And we decided to increase the performance for that part only, and it is our plan to publish the result by the end of this year. So we are currently conducting generalization related research, and we want to have the performance that can be generally performed. And also we want to make a study that can have a good sensor result. So far we have followed a natural language autonomous driving scenario, but if we finish this research, then we can apply this to other research. Thank you for listening.
Thank you for the informative presentation. Ladies and gentlemen, please give another big round of applause to Professor Im Sung-han. Thank you. As we approach the final presentation of the day, the topic is the new utilization of technology, artificial intelligence for research and public good. The advancement of AI technology is reshaping various sectors of society, including the industrial landscape. Going beyond merely earning profits, recent research efforts have been actively exploring how AI technology can benefit society and create additional value. So our last speaker will be highlighting several examples of that. Let us invite Professor Chon Hae-gon from GIST with a big round of applause. Hello, good afternoon. My name is Chon Hae-gon. I'm from GIST. Well, before I start my presentation, I think I would need to explain my title, and then you will understand what the talk will be about. And the topic is this. I feel like my clicker is not really working well. Why is it that happens now? Does it work? Okay, so while preparing, let me just continue. So this is the topic, tech upcycle. Upcycle, as you may know, is an environmental terminology. So do you know what recycle is about, right? It is about reusing the things that we already used. The upcycle is about this. After using things, then we can use the things again with added value. So this is the topic. It's about upcycle of technology. Why is it that I come up with this idea? I mean, our lab's also working on computer technology, but in the lab, our capacity, 20% of it, is around the artificial intelligence for public good. And the concerns that I personally have some connections with this study area, and I would like to unveil that for you. So this slide, I believe that you have already seen this slide before, right? So we have seen development of artificial intelligence. I mean, during my PhD, I saw AlphaGo, was competing against Isidore, I thought something really big is happening. And here, what I wanted to point out is that there have been numerous breakthroughs, and these are all made by private sector. And this massive R&D budget of a nation, I mean, not just our AI graduate school and your research as well. All this, budget and taxpayers' money, it is about making the R&D outcome. And then because of that, this actually benefit the private sector. But starting the mid-2000s, major Canadian and American research groups started to think as follows. I mean, maybe our study around AI is focused on the profit making. So with that, Google and the Triple AI and the major conferences started to discuss that maybe it's a time for us to stop focusing the AI funds in profit making technology, but now maybe it's time for us to provide funding for AI for public good. So this movement started to rise starting 2018, 2019. So there's an AI for social impact track at this AII conference. So justifiable AI, I mean, there are some even studies around correcting the hate comments, and at machine learning major conferences, they started to deal with topics like the climate crisis or wealth redistributions. So these has been now categorized as a single category, actually. And I think you're all aware of it, right? So when utilizing detection algorithm, some algorithm identify white as humans while recognize the black as animals. And there are different types of algorithms that started to work on different things. And let me just explain about this. When we walk on the street, then this algorithm utilizing visual perception would let us know how dangerous or how risky it can be. And it was all released in the paper. And at UN, Sustainable Development Goal, there are 17 big topics ranging from environment, food, wealth redistribution, and the gender equality. And all of this, as I mentioned in the very beginning, at the social impact track at the conference, this has also been categorized as a separate topic. And in fact, if we think about it, we started to receive these papers around this topic, right? It hasn't been quite long. It hasn't been long. And for the AI impact, this topic only accounts for 2%. That shows a small door. And you see the submission ratio. The papers around justice and around climate change, it only takes 1% of all. And you see, if you look at the portion of the most accepted papers, only at 0.7%. So, AI for social good or AI technology that benefit the society, but people say the door's open. Well, I would say then for some subjects, some other subjects of research, the doors can be large, but I would say for these doors, relatively small. And I've been telling my students about it, but I can't really say with confidence that we should really work on this area. There are some realistic challenges. Then why is it that we look at the major conference paper? Every time I try to, publish the paper, it really makes me stay up late at night. Then why is it that I should, really bring this up? Major companies started to focus on this, right? When big companies, when they recruit PhD students, they look at how many papers these students have written. this world-best technology is important, and one has to have the skills that is to persuade others into their technology. So once it's published multiple times, that the companies would understand that, of course, they understand that this kind of technology can happen, and these can effectively delivered, and this has seen as the verification by academia, and that is why these companies look at these conference papers and see, I mean, even for recruiting professors, how many papers you publish matters. And if you go into the detail, if you access the Kimbaksanet, you can see all the discussions are very heated around it. And personally, I have to say that, CVPR versus nature, I mean, I personally know that the nature is difficult, but CVPR is the same. It's very challenging. I mean, publishing the paper, there would hold a huge value. So for us, these market conditions cannot be ignored. So this is my personal dilemma. So, I mean, our lab's capability, whether we should work on writing major papers or whether we should take rather pace a path towards AI for social good. So this is the real dilemma. And I chose the reality. So I've been actually publishing papers to the major conferences, but well, I already brought this up with other places, but to me, only focusing on writing major papers would not really fulfill everything for me. So these technologies utilizing for social good, well, this is another thing that I do. So I'd like to share with you 3 different cases, and I want to go over one by one. First is this. It's the study around predicting typhoon trajectory. And we recently submitted a paper, and let me begin with how it all started. And this is actually a video, and do you know how to play this? If you could mouse click. I mean, I saw the animation played, why is it that the video can't be played? Okay, now it's working. You see, this is an area called human trajectory prediction. What it is, it looks at the trajectory of a person, and then by looking at the trajectory, it predicts within 5 seconds of time or 10 seconds of time where the person will be headed to. So this is used in the following area: path planning or robot navigation. So then this trajectory, I mean, for understanding trajectory, why do we need to consider? There are 4. First is group walking. If you go to the canteen, you group walk, and that's what it is about. And the second is sometimes you join the group, right? And another case is that there's a grouping with intention, and just as this blue guy, there's a tendency of collision avoidance. So the core here is modeling this for. So what we do at our lab is that we utilize the graph node And we look at the distance between people, and we look at the variations, and utilizing that, we create graph. And this doesn't have to be, reviewed thoroughly. And by doing the modeling, what we do is within 5 seconds, in which direction and how far the person will move. And this is the algorithm. At the core is this person now, where the person is, and as the time changes from the person's point, in which coordinate that this person or the people around the person will move along. And as you can see, well, this is a probability map, and what it means is that it shows that this person's future trajectory lies within this probability map. And then we took this further. So we once saw on paper that 70% of people will form groups. So by identifying the group, we can largely increase the algorithms. So capability. And it's not that we do the separate prediction. What we do is that we predict these people's trajectory as a group. So we basically create a graph, and a graph for individual. And what we do is, well, the professional terminology is a hypergraph representation. And if we use that for prediction, if we had to predict 10, now it only requires for us to analyze 6. And by doing that, we can improve the performance. And if you look at these, we had this one proposal by a company. I mean, they are working on this typhoon trajectory prediction. Like, they wanted to adopt our algorithm. And think about it. I mean, it really matters to forecast precisely where the typhoon will go, because it can cause various damages, right? So, typhoons in a certain area, at max, there'll be 2, right? So just a slightly different environment. Then what are the other variables? That would be the temperature of the water and the wind directions. And what is important in predicting typhoon is that the interaction between the typhoon and the surrounding environment. So here's what we adapt is a 2-stage training, and the first is this. At the transformer network, we added the decoder, and this is not the image value. This is actually the number values. So we look at the temperature and the wind directions. We put it in the numbers, and then there will be the environment map, and this is the first training phase. And the second phase, we just like we did with the human trajectory prediction, we look at this trajectory for a certain degree, then we make predictions with our algorithm. Then why is it that it has advantage? There's a paper released in Nature. It's about reanalysis data, that is utilizing the existing typhoon trajectory data. I mean, comparing that with our real-time algorithm. Let's say the typhoons up to Jeju, whether it would go to Japan direction or the Korean Peninsula direction. When tested, there was an average error of 200 kilometers, but according to our algorithm, the error degree was up to 70 kilometers. And the second case is the artificial intelligence algorithm that can be applied to disaster relief situations. And actually, these release was done along with our previous speaker, and I believe that you know the importance of 3D technology, right? Let's say that when we buy a product, or we go to the website to find a place to rent, or in various applications, 3D estimation is very important. And what's core is not just the 3D reconstruction, I mean, doing 3D reconstruction itself means that it understands the location of camera, and that way we can form the 3D, and if we can find 3D, then we can easily find the location or poses of cameras. So here's what we thought. I mean, as it was explained by Professor Myung, for those work instructors, the technology can help, but our perspective is that we took the computer perspective, and let's say that there's a department store on fire, and how the sufferer let their location know. But the problem is that there's not enough data set. And, we thought that, okay, how should we do? Then what was in fashion back then was seemed to real. So in virtual setting, we make the data and we transform to the real world. And in 2017 and 2018, it started to emerge. So the 3D assets, we purchased a 3D asset.
So we bought the normal asset and then we put in general effect, a disaster effect like this. Do I have the control for the video? I will skip this video. So this is the general situation. So we put on fire effect and then we get the label for that. And then there is a torch, and also the fire effect comes out like this. So we can simulate the fire inside the building. I don't know how it goes currently, but by that time, sim trial dataset was very good. And also, this goes to the same with the other scenario. But what we have thought about is when there is a fire or earthquake. Have you seen the movie Tunnel? The person in trouble can take a photo and then send that to the fire station, and then the fire station will get the location information. If that should be possible, then the photos should be took before the fire actually burns everything. So after there's a fire, it is very difficult to match before and after the fire. So we have thought about domino adaptation method, and I was the first one that had used that research. Of course, we all used it all together. And our idea was, this is normal condition. We put in numerous textures, and that will become the basis. And that basis, when there is actual disastrous condition, it can be used as visual localization. So this is how it goes. When there's a fire, we use Google building on fire image, and then we use style transfer to the database, and then we visual localize train. And as you can see, if we assume that there's a fire, it can find the location very well. And that was the second part, and I have about 7 minutes left. I will be fast. Lastly, we have recently developed virus detector. We are very much interested with 3D reconstruction skills. We are very much interested. As you can see, some iPhone users will be equipped with IDAR. So it measures with this sparsity, and it disperses the image based on this 3D image. LiDAR is the same. So it only has 1% of measurement. So by profiling, it has special propagation or depth completion. And as for semantic segmentation, when we refine the traditions, semantic segmentation and spatial propagation is for sparse input measurement, and the purpose is to expand that sparse information. So this year we have announced that how can we effectively propagate this data. So in non-nuclear phase, we can distort the image space, and then we can mix, change the image mix, and if we do the right filter, it can disperse in the right way. But I won't go deep into it. But recently we have made a published announcement about this, and this was very similar to propagation. And also Professor Song, who is also working on same computer electronics, and in the life science laboratory, they came up with a sensor, and that sensor was very sensitive. It can also sense nanoparticle. So if that nanoparticle is attached to the sensor, then it won't see if it's attached or not. The problem is you don't know how much nanoparticles are attached. So they asked us how we can figure this out with machine learning. If a nanoparticle is attached to a sensor, then you can count how many nanoparticles are attached to the sensor, one by one. And this is the sensor that has been studied by Professor So, but we don't know how many particles are included. That was the issue. So this is the sensor from his laboratory, and when we make a photo shoot, we could see that particles are attached like this. So we made photos about 1,000 particles, and we also annotated, and we made some analysis. So think about it. You reverse this, and you saw that depth completion. If you make dense, if you predict dense to sparse, then you will probably know the number. Then you will be able to spread the virus. That was our observation, and this is the related network. So we inversed spatial propagation. That's how we got the right number. And if we design rule-based algorithm, the actual number and predicted algorithm was very different, so accuracy was very low. But by applying machine learning, we can able to predict more accurate way. So this is a cheap sensor, fast responding sensor, but the performance is increased with artificial intelligence. This is the conclusion. Our laboratory has core technology that is under development, and we also entered a major conference and major journals, and we use about 60% of our resources for this research. And also there is trajectory prediction technology, and that is for typhoon direction prediction, and that prediction was the world first real-time prediction. And we suggested the algorithm which is much more better than the existing one, and we upcycled based on the location tracking. And lastly, spatial propagation. For virus detection, we consider the inverse process of the spatial propagation. Lastly, these are my colleagues that helped me with the research. Thank you. Thank you for listening.
Thank you for your meaningful presentation. Ladies and gentlemen, please give Professor Chun Hae-gon another big round of applause. Thank you. The world of AI shining here. AICON Gwangju 2023 has concluded its 3-day grand journey. Throughout this time, we were joined by 25 global leaders sharing insight, and I believe that we did spend meaningful time together. Once again, thank you very much for your participation. And this is our last part of the event. We'd like to proceed with the lucky draw. For those of you who are here, I believe that you're automatically registered and you'll all have a good chance of winning.